Hello guys, welcome to Slope Academy. This is the fourth part of differentiation that I'm going to discuss today. And our today's topic will be turning point. In this video, we will understand the concept of turning point. Then after that, we will solve some of the questions related to this concept. So let's get started. Turning point we will understand by observing our graph. So here I have plotted a graph in x-axis and y-axis. In both the axes I have taken points up to 8. Now this is a curve that I have drawn on this graph. Let's begin this curve from here. So it is going upward, 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 and then this is a point from where this graph is turning downward. So this is our first turning point. Similarly, now this graph is going downward, downward, and then from here this graph has started to go upward. So this is second turning point. Similarly, we have third turning point, and this is fourth turning point. So turning point basically means that it is a point from where the nature of the curve is changing its direction. For example, from here to here it is going upward, but after this point it is going downward. This is graphically. And what is the definition of this turning point or stationary point is? It is a point on the curve. This is our curve. It is a point. These are the points on the curve where gradient is 0, or we can say where slope is 0. So if we determine the slope of this point, then we will get always 0. And slope means we already know. We have discussed in previous class that slope or differentiation or tan or gradient, these all are same concept but having different name, but meaning is same. And next our concept is local maximum and local minimum. So just observe this graph. Okay, so where is the maximum point in this graph? So if you observe this is point, point number third, that means turning point number third is the maximum point plotted on this curve. So this is local maximum. Similarly, if they are asking us to determine the local minimum, then again we will observe the graph. So this is minimum and this is minimum. Now compare if this is more minimum or this is. So of course this is. So this is our local minimum. So in this particular graph, turning point number 2 is local minimum, and turning point number 3 is local maximum. So now we can say that since the value of gradient on at this point, this point, and this point is 0. Therefore, we can say turning point is a point where slope is 0, where gradient is 0, or where differentiation is 0. Therefore, we can say slope equals to gradient is equals to derivative is equals to y dash is equals to f dash x, all of them is equals to 0 at the particular point. So this is graphical notation understanding of turning point. Now I will discuss the concept of the turning point using some equations. So now we will understand how to solve turning point questions if we have provided with equations. So here I have taken y equal to fx is our equation. So first of all we have to differentiate this equation, that is y dash is equals to f dash x. Then we will put f dash x is equals to 0 and determine the value of x. Then after determining the value of x, we will put the value of x in this equation and determine the value of y. So this is the coordinate of turning point x and y we will get by solving this equation. Then after that, one more concept is we have to also determine the nature of the turning point, whether the turning point is minimum in nature or whether the turning point is maximum in nature. So for that we have to double differentiate our the equation. So first of all what we have to do is we have to differentiate twice our this equation, and the value of x that we have already determined, we will put the value of x in this f double dash x. If after putting the value of x in f double dash x, the value is positive or greater than 0, that means that the nature of turning point is minimum. And if by putting the value of x in f double dash x is less than 0 or negative in nature, that means our turning point is maximum at there. For example, like suppose I am making so that you could understand it in better way. This is our curve. So from here, let us take this point and this point. So from this point, the curve starts to go downward. That means this is a point of maximum, and from here, curve starts to go upward. It means that this is a point of minimum. So minimum turning point is this and maximum turning point is this. Now I will solve examples. Find So now we will solve some of the questions. Find the coordinate and nature of the turning point. First question is fx equals to x square minus 3x minus 5. This implies we have to first of all determine the differentiation. F dash x is equals to 2x minus 3. Now we have to put f dash x is equals to 0. This implies that 2x minus 3 is equals to 0. This implies x equal to, we have 3 by 2. Now we will put this 3 by 2 in this equation. Therefore, we will get 9 by 4 minus 9 by 2 minus 5 equals to, this is 4, this is 9, this is 2 to the 4, 18, and this is 20 is equals to, this is 20 plus, this is our 38, 38 plus 9 is our 40, sorry. Minus 29. Start. So now we will solve some of the questions on turning point. Our first question is fx equals to x square minus 3x minus 5. So first of all, to determine the turning point, we have to differentiate this equation. So f dash x is equals to 2x minus 3. Now f dash x we have to put is equals to 0. This implies 2x minus 3 is equals to 0. This implies x equal to, we have 3 by 2. Now we will put this, the value of x 3 by 2 in this equation. Therefore 9 by 4 minus 9 upon 2 minus 5, which is equals to, this is 4, this is our 9, this is 18, and this is 20 is equals to, we calculate this, this is minus 29 upon 4. So the coordinate of this equation, that is turning point equation, coordinate is our x is this 3 by 2 comma minus 29 upon, or let us take now, since in this question we have to also determine the nature of the turning point, whether it is a minimum in nature or whether it is maximum in nature. So for that we have to double differentiate the equation. So our equation is this, and let us take, I am taking again because this is the first question I am solving. Fx equal to, we have x square minus 3x minus 5. So f dash x is equals to 2x minus 3, and f double dash x is equals to 2. So this 2 is constant, no variable attached with this 2. That means whatever value we will put, it will always come 2. That means this is positive in nature, or greater than 0, or positive in nature. Then, as I have already discussed, if f double dash x is greater than 0 or positive in nature, therefore turning point will be minimum. So this is done. Now we will solve next question. Let us take fx equal to, we have another question. Example number 2. 2x cube minus 2x square minus 3. So our first step would be to differentiate this equation. Therefore, f dash x is equals to 3 to the 6 x square minus 4x. Now we will put f dash x is equals to 0. This implies that 6x square minus 4x is equals to 0. This implies we will take 2 common and x also common. So this is 3x minus 2 is equals to 0. This implies that here from here we have x is equals to 0 and 2 upon 3. Now when we will put the value of the x equals to 0 in this equation, we will get y equal to minus 3. And now when we will put x equal to 2 by 3 in this equation, so let's solve. 2 into 2 to the 4, 4 to the 8, 8 to the 16 upon 27 minus 8 upon 9 minus 3. So 27, this is 16, this is minus 24, and this is minus 27. So this will come 16 minus 51 upon 27, which is equals to 10 minus 41, 6 minus, it will come 35 upon 27. So our coordinate will be, when x equals to 0, y equals to minus 3, and when x is equals to 2 by 3, y is equals to 35 upon 27. So this is the value of coordinate of turning point. Now we have to also determine the nature of turning point, and we already know that for that we have to double differentiate the equation. So our first order differentiation is 6x square minus 4x. So I am proceeding from here only. So f double dash x is equals to, this is 12x, and this come minus 4. Now we have x equals to 0 and x equal to 2 by 3. X equals to, we have 0 and x is equals to 2 by 3. Now if I put the value of x equals to 0 in this equation, so f double dash x, 12 into 0 is 0, minus 4 equal to minus 4, which is less than 0 or negative in nature. Therefore this, therefore this is the point of maximum. Now we will put x is equals to 2 by 3. Therefore f double dash x is equals to 12 into 2 by 3 minus 4. So 3 4 is 12, 4 is 8, 8 minus 4 is 4, which is greater than 0 or positive in nature. Therefore it is minimum. Done. So from here we can say that this is the coordinate of 0 comma minus 3. When we have put the value of 0, we got this maximum. This is the point of maximum. That means nature of turning point at 0 comma minus 3 is maximum in nature. That means the curve must be going like this something. This is maximum in nature. And the nature of this curve at the point 2 by 3 comma 35 is minimum. So the curve must be something, the point must be like this, minimum. So this is all for today. Thank you for watching my video. If you like my video, do share it with your friends and subscribe to my channel.